Good evening, good morning, and good afternoon. My name is Gianfranco Campos.
Hi, my name is Pablo Bellido.
Hello, my name is Israel Lopez.
And we are the Oxy Node team that developed the solution for tracking oxygen and pulse levels for the IOT2TANGLE Hackathon 2020. Pablo is from Peru. I am from Peru too. Pablo is in Peru. I'm in Canada. Israel is from Mexico, and he's in Mexico. So we gathered remotely together to build a super exciting application that we are gonna share with you now. So I'm gonna start with our GitHub repository, and I'm going to walk you through all the wikis and documentation that we have prepared for this project. So the Oxy Node is a secure remote control for oxygen and pulse levels. The Oxy Node works by integrating an ESP32 MAX 3102 sensor, a display OLED, and a 3D printed case, and an Oxinode version of the I2T2TANGLE stack. Standards we use as part of these projects are the I2T standard, the IOTA Streams framework, which uses channels as its core protocol, and ESP IDF standard. What does the Oxinode do is essentially sends pulse and oxygen data to the Tangle through the I2T stack. The developed system can be used to alert through Telegram patient relatives and friends about the blood oxygen and pulse levels of the patient. It can also be used as quick mechanism to detect possible symptoms of COVID-19. A potential tool for physicians to take oxygen and pulse measurements that they can rely on as well. And that is because the IOTA Tangle is a tamper-proof network that essentially secures the data in a way that third parties can rely on the data that they retrieve from there. The potential. So the same principle could be applied with wearable technologies such as a smartwatch. We can add other sensors, for example, a GPS, a temperature one, and have a full picture of the end user physical activity. Thanks to IOTA Streams framework, the user will always be in control of its own data, and the user can profit by deciding who and when others are accessing to the produced data. For the purpose of this project, we haven't explored the cryptocurrency part of it. We have focused only on the data side of the project, but as the IOTA framework or IOTA protocol is essentially combining these two together, it should be, or it's going to be very easy to jump from what we have developed to commercializing the data. Future challenges. As part of this project, well, we foresee that reducing the size of the prototype, for example, or instead of reducing the size, maybe jumping directly into a smartwatch and develop the application to read the sensor data and send it to the Tangle through LTE or Wi-Fi. So this is a wiki, and on the right side, we have different pages that we have prepared in order to let you understand what all of this project is about, and not only that, but also to replicate what we have built. So our purpose is to allow you to build your own Oxy Node and play with it at home. The sensor MAX 30, for example, collects the data for oxygen and pulse levels, and then it sends it to the ESP32, which has installed the ESP32 MQTT repository or application, which was developed by I2T standard or the IOT2TANGLE standard. Then the information is sent through MQTT to a Hornet node, and this Hornet node has a MQTT broker and a stream gateway application. So when the ESP32 reaches the web application at the Hornet node, it writes the MQTT database and it publishes or it sends the data to the string gateway, which is the one who signs the data or the records in the IOTA2TANGLE, and that is where the data is essentially tamper-proof. Then a third party can read the stream channel ID and download the records that we are submitting or pushing to the Tangle. In addition, well, we have set up a Telegram bot to essentially alert patients, as we mentioned before, and we have set up a CSV export option for reporting. Now we're going to see the implementation plan. So we have listed all the components as part of this project, and we have essentially a purchase list right here with the specific components that we have used. We also have an Oxinode 3D case component, so you can print off the case that we have used, and we have obviously the architecture diagram that I've shown you. We have also a circuit diagram to let you connect the dots, essentially, which is right here. So this explains you how to connect each pin from the ESP32 to all the other devices and have the system up and running. Here is a 3D model case that we have designed for this project, and that's one of the pieces, and there are another 4. And as part of the project, as we mentioned, there are also software components. So we did a modification of the I2T sensor stack, and essentially we create this ESP32 MQTT application that was reading all in C, and essentially is the one that lets send the data to the MQTT broker, which is installed in our Hornet node. What is Hornet? For those who are not familiar with Hornet, Hornet is the node from the IOTA Foundation that it's used to process and validate or help with the data with the transaction validation of the IOTA network. Oxy Node web application, we developed this. Israel Lopez was the one who mainly put all the code together and all the other pieces to bring up this marvelous application. And then the Streams MQTT gateway, which is the other piece that I've mentioned that will sign the data in Tangle, and the Stream subscriber. So now, well, we are going to see how this system comes together. Pablo, could you show us the system that you have in Peru right now? Okay, so now Pablo is going to show us the prototype of the Oxy Node. Right now, Pablo is pressing the sensor to detect his oxygen level and pulse level. And well, the display is showing those values. And remember that this data is being sent to the Tangle in real time. Perfect. So, well, that case is empty right now, but all of that fits inside that. Believe in me, that works. We have tested out, but the thing is that we use different pins to connect all of that within that case. Now let's jump again to our, and now I'm gonna show the marvelous website that Israel Lopez developed. Israel is only 19, so he barely has the majority of age in our team.
First, we have to complete the registration and login process. Once completed, we will access the application in where the patient's data is going to be presented. The oxygen level and heart rate per minute are sent from the Oxinode to the IOTA2TANGLE, which is tamper-proof and allows to have reliable records for third parties. Simultaneously, the data is displayed in the Oxinode web app and can be accessed by any authorized remote user. This information is also stored in our local MQTT broker, where specialists can accurately observe and select time frames to build dashboards. The specialist is also able to define parameters based on their knowledge to receive notifications in real time through the Telegram mobile app and determine the situation of the patient or advice user. To facilitate access without having to visit the website, any subscriber can consult the last data obtained for the oxygen or pulse directly from the Telegram app. Finally, to get a record copy of the patient data, the specialist can download a report in CSV format spreadsheet when convenient.
On this tab, we have also the Oxinode web application and specific instructions to install the application that we have developed for this project. You just have to follow the commands, read the instructions, and you will get to the dashboard, or you will get to this end result. We have also prepared how to set up an MQTT broker, and that's pretty much it. Thank you so much, and please stop by our repository. We are going to be updating and developing the technology further, so let's stay in touch. Thank you.